problem, we need to remember three things. The first is an angle um, that is centered at the center, or that has a vertex at the center, is equal to the arc of that angle. An angle that has a vertex on a circle, like this one right here, is 1/2 the arc that is inside the angle. And then one like this one that is centered neither on the circle or on the center is 1/2 the average of the two arcs. So let's go through and look at the arcs first. So we start with, well, actually, we got angles first. We got angle DBE is 64. Well, that angle is half the arc, so that means that angle DFE is twice 64, so 128. And then you're given that angle F, or that arc FE is 48, which means DE is 80. Now, because A is the center, DB is a diameter, which means DFEB, that arc, is 180. So we can subtract 180 minus 128 to give us 52. And so EB, arc EB, must be 52. Then you're given that BG is 116. We can use the same logic we just did, 180 minus 116 to get 64. So arc DG is 64. All right, you want to find out what angle FHE is, so this angle right here. Well, it's going to be the average, 1/2, of the two arcs, FE and DG, that are between it. So 1/2 times 48 plus 64. Adding those together, you get 112, so half of that is 56. So FHE is 56 degrees. And then the other one you want to find is HIA, and so HIA is this angle, and so it's going to be half the average of the two arcs it's in between, which are 64, because it's this angle here. These angles are the same, right? So 64, and then all the way around here, which turns out to be 48 plus 52. And so the average of 64 and 100, 48 plus 52 is 100, which gives you 164. And so that angle just turns out to be 82 degrees. You could have also found that angle because you would know that this angle is 124 because it's a adds up 180 with 56, and then this angle is 90, and so you could have done a quadrilateral calculation, 360 minus 90 minus 64 minus 124 to get your 82 degrees. And so HIA turns out to be 82.